Okay, class, this is so that you can have all of the examples in one place. We're going to work step by step through each of the chapter review questions, starting with number 1. So, for number 1 and 2, I was needing you to graph the problems. Let me get to a... Okay. So, for number 1 in the chapter review, y is equal to 2x minus 3 and y is equal to x plus 2. They are already in slope-intercept form. So again, identify the y-intercept and identify the slope, and then you will graph based on that. So I need to, and it's going to be, you know how difficult it is for me to do these on this technology, but I'll do my best. The first equation has a y-intercept of -3, so you would place a point at -3. The slope is 2, which means 2 over 1. So I'm going to kind of summarize. M is equal to rise, which is the change in the y-axis, over the run, which is the change in the x. And in this case, since it's a positive 2 over a positive 1, my movements will be to go up first and then over to the right. So I will go up 2 and over 1, up 2 and over 1, up 2 and over 1. Now notice I'm doing this in multiple points, right? I could draw the line, but you know that if I don't have a ruler or if it's not perfectly straight, they might not intersect. So now looking at the second equation, I'll change my color here so we can see where they'll possibly intersect. The second equation has a y-intercept of positive 2. And in that case, the slope is 1, right? An x by itself has a coefficient of 1. So in this case, m would be 1 over 1, and they are both positive because it's a positive slope. So I would go up 1 over 1, up 1 over 1, up 1 over 1, and eventually these two are going to be on the same point, and here it is, right? This is my solution. If I were to draw the two lines, which I do want you to use a ruler, a straight edge on your test, but I need you to identify the place where they intersect. So starting at the origin, I go to the right 5 and up to the top 7. So my solution is 5, 7. Okay? Let's look at number 2, and we will also be graphing, and in number 2 I get y is equal to a negative x plus 4 and x plus 3, y equals 0. So I have to put the second one in slope-intercept form, which means I need to get y by itself. So I subtract x from both sides. 3y is equal to a negative x plus 0, which at this point really that 0 would be the y-intercept, is not going to be necessary because it's just going to be 0. Because the last thing I'm going to do is divide by 3. So y is equal to a negative 1 over 3x. Whether or not you write the 0 or not is up to you. So I'm going to keep this blue one for this equation. And so let's graph this one down here that I just solved for. Since it has a y-intercept of 0, okay, that's where the first point goes on the y-axis. My slope, m, is equal to, since it's negative, I'll just make the top one negative. The only reason that you ever sometimes make the bottom one negative is if you run out of room on your graph. So from that point, I could go down 1 and over 3. Okay, from there, down 1 and over 3, and continue. I'll change the color and I'll graph the top equation. So the top equation right here has a y-intercept of a positive 4. For my top equation, my slope is equal to a negative 1, which happens to be negative 1 over positive 1. So down 1 and to the right, down 1 and to the right, down 1 and to the right. And notice this pattern is going to continue until I eventually intersect, and this is the point where I intersect. So my solution would be, I would say the x-coordinate first, 6, negative 2. All right? Now you can always substitute those back into the original equations for x and y, and you should get a true statement. All right, number 3 was not as easily done by graphing because it turned out that when you solved it for y, you get a fraction for the y-intercept. So I'm going to do number 3 either by substitution or elimination. Let's do substitution because in the first equation that x has a coefficient of 1 and I can easily solve. Okay, so I'm going to use, so x minus y is equal to -2, and my second equation is 2x minus 3y is equal to -2. So I'm looking at this being a pretty easy thing to do because I could solve for x by adding y to both sides. Okay, so I rewrite that so that it is x is equal to, because these y's would cancel, and then I could do, I like to put my variables first, it's just a habit, y minus 2, so that's a -2, or you could do -2 plus y, it really won't matter. So now I want to use this expression for x to substitute it in the second equation for that x. You always have to look at what the variable is that you've isolated because that's saying that x is equal to this, or it could be equal to this. So now I'll rewrite the second equation, substituting in this expression, bringing down the rest of the equation. Literally, I'm just copying the rest of this part down, okay? And now I have to distribute, right? So 2 times y and 2 times a -2. Bring down your 3, y is equal to -2. Combine some like terms here. See that that's a -3. So 2 plus a -3 is a -1, or a -y, minus 4 is equal to -2. So I add 4 to both sides, and I'll get -y is equal to 2. So I'm dividing by a -1. And I'm going to get y is equal to -2. Now I have to substitute that back in to one of my original equations, and if I solved it correctly here, I should have -2 minus 2, so x would be equal to -2 minus 2, or x equals a -4. So my ordered pair is -4, comma, -2. Problem 4 is more substitution. Problem 4, y is equal to -3x minus 7, and y is equal to x plus 9. I could substitute this in for this, so I rewrite the whole equation. And now I need to get the x's to one side, so I will add 3x to both sides, keeping in mind that I can only add like terms. So -3 plus 3 is 0. Always check your math. 1 plus 3 is 4. And this is a -7. So I will be subtracting 9 and subtracting 9, which means that I will add those because they are like terms. So 4x is equal to a -16, and when I divide by 4, I get that x is equal to a -4. Now, I have to go back into one of my first equations and substitute that in right here, okay? So I would get y is equal to a -4 plus 9, or in this case, y is equal to 5. So my solution is -4, comma, 5. Still on substitution. Number 5. Oh, I know, these fractions bum you out, but it's okay. The second equation is already solved for y. So I can substitute this in for this and rewrite the entire first equation as 1/2 x plus 2x plus 16 equals -4. My like terms are here. And I'm going to go ahead and change it to a decimal because I know you like those better, but you don't have to. So 2.5x plus 16 equals -4. So I subtract 16 on both sides and get 2.5x is equal to a -20. When I divide both sides by the 2.5, I will get x is equal to, and this one will be -8. When I come up here and plug that in, 2 times -8 plus 16, this is what y equals, I get -16 plus 16, so y equals 0. So -8 0 is my ordered pair. Number 6. Negative x plus 5y equals 28, and x plus 3y equals 20. Don't make it harder than it needs to be. This seems to be the variable that has a coefficient of a positive 1, so if I subtract 3y from both sides, I rewrite it to be x equals negative 3y plus 20, and that gets substituted in for this x. Now don't forget that that x is behind a negative sign. So when I do this, I am truly distributing a negative 1. So some of the things that you'll get hung up on will be all of these integers and all of these negatives. We all make silly mistakes. Just be conscious of what you're doing and then go back and check it. So a negative 1 times a negative 3 is a positive 3y. A negative 1 times a positive 20 is a negative 20. Bring down the rest of the equation. Combine like terms, so 8y minus 20 equals 28, add 20. So 8y is equal to 48, so y, in this case, must be equal to 6. And if y is equal to 6, right, negative 3 times 6 plus 20 will be equal to x. So a negative 18 plus 20, and when you have a negative and a positive, you're going to subtract, so x is equal to a positive 2. So 2 comma 6 is the solution for number 6. Number 7, the solution is posted. I'm not going to take the time to explain that because that is setting up the word problems like we've done in the warm-ups all week. And I'm going to move on to number 8 because we still have quite a bit of problems to do. It looks like in order to keep this video at a regular length, I might just have to explain some of the steps on the next page without doing it. Otherwise, it'd be like a 25-minute video. So we'll try to get through, 8, 9, and 10 at least. All right. So let's look at 8. Here, when we get to this page, it's kind of like your choice because it just says solve it. It doesn't really say how or why. So one thing you could do in these types is solve for y, put them in slope-intercept form. Then you could determine, is there one solution, no solution, or infinitely many? And I'm going to go ahead and tell you, I know for number 8 there is one solution. So I'm going to go ahead and, instead of rewriting them, I'm just going to go ahead and solve them because they're set up pretty quickly. And honestly, even if there is one, or no, or infinitely many, when you have a system like this, it's set up really nicely for elimination. So elimination is the concept of, if I were to say in this case, because I look at the y variable, I have a positive and a negative 2, those are inverse operations, right, that result in 0, I could add going down. So if I'm adding going down, I have 1 plus 1 is 2x. Positive 2 plus negative 2 is 0, so that's eliminated. And negative 5 plus negative 5 is negative 10. So if I divide by 2, I would get x is equal to a negative 5. Okay? Now I could go back into my first equation and do negative 5 plus 2y is equal to negative 5. So if I add 5 to both sides, I get 2y equals 0, which means y equals 0. So my solution, negative 5, 0. Elimination is a pretty quick and easy way to solve. For number 9, I could look at that and immediately start doing elimination by maybe multiplying the first equation by negative 3, or I could solve them both for y. I'm going to go ahead and solve them both for y so we can kind of examine them first. So I'll start with the first equation. So if I subtract 3x from both sides, I would get negative 2y is equal to, sorry, that's an x, negative 3x plus 1, and then I'm dividing by a negative 2. So y is equal to, a negative divided by a negative is a positive, so I have a positive 3 over 2x, and then we have a 1 divided by negative 2, which is like negative half. I know, nasty fractions. Looking at the second equation, 9x minus 6y equals 3. subtracting the 9x, okay, that goes to 0, negative 6y is equal to a negative 9x plus 3. Now I'm dividing by negative 6, and I'll just be able to like simplify these, okay? So y would be equal to, a negative and a negative is positive, 9 and 6 are both divisible by 3, so 3 over 2x, you can already see they have the same slope, and 3 divided by 3 is 1, 6 divided by 3, so a negative 1/2. Not only do they have the same slope upon inspection, they also have the same y-intercept. They are the same line, and there are infinitely many solutions. And I can't spell infinitely. I think I just needed an extra, I don't know, something like that, but it's infinite solutions. So if we would have solved it another way, we would get something, and it's an identity. It's like a 0 equals 0, or 2 equals 2, or 5 equals 5, or something that is always true, right? If this is always true, so you did substitution, you did elimination, and you get a weird answer because there's no variable, then it's infinitely many. Number 10. Number 10. 8x minus 2y equals 16, and negative 4x plus y equals 8. I'm going to tell you right now, the lines are parallel. We could solve for y. But I'm also going to show you what would happen if we tried to do another form of elimination. Because when I look at this, I know that I could multiply the second equation by 2, and my y's would cancel out. So let's see what that looks like. So I'm going to multiply. So I have to multiply this by 2, this by 2, and this by 2. So 2 times 8, oh, look what happens. Negative 8x plus 2y, and then 16. Now I'm going to add, and I have 8 plus a negative 8, which is 0, right? So 0, and then negative 2 plus 2, another 0, and I have 16 plus 16, which is 32. So 0 equals 32. What happened? I literally, just by doing the elimination, something's weird. The variables are gone, but I get a statement that's not an identity. It's not always true. It's never true. If this is never true, you just saw what it looks like for parallel lines and no solution. However, if you put them in slope-intercept form, they would show that they are parallel because they would have the same slope but different y-intercepts. So the answer here is no solution. So I'm not going to go through and explain everything in the page 236. I'm hoping that you picked up a few things that you might have been messing up on through this explanation, and if you can get these right and try to apply that to the problems on the next page, you should be in pretty good shape. You will have these solutions, you'll see the solutions to the page 236. That will help you be able to check, because you need to be able to do these independently and be successful on the test. So good luck, everyone.